The objective of what we've got currently going on out at the Blue Creek Station that we'll have a chance to take a look at later on this afternoon is really more of a long-term observation, not year-to-year impacts of no-till and chemical fallow systems on dryland agriculture, but really more of, we're looking at decades worth of opportunity here to observe the impacts and look at some of the things that really are a lot harder to place a value on. We had Lyle up here just now going through some of the, the dollar enterprise budget stuff, the profit kinds of things. But how do we put values on things like, crop quality? There might be some opportunities for premiums on things, but I know that, when we're talking about raising wheat for a specific purpose, we're worried about quality, and that can make all the difference. Erosion protection, obviously, we've talked about already, but what about other things that we may have opportunity to tap into revenue streams that didn't exist before that would help us bring our receipts up with some of these no-till systems like carbon accumulation, soil quality and long-term productivity, soil structure and things like that, and weed ecology down the line. So a lot of these kinds of things are harder to put dollar values on and really hard to do if we're looking at just year-to-year kinds of results on things and not really long-term. So we've really tried to back off and concerning ourselves with the early returns on some of this research, recognizing that we want to kind of get things moving in and kind of a settling in period the first few years, and that we begin to really track the differences in what's going on with the comparisons between the conventional tillage and fallow systems with the different iterations of the chemical fallow direct seeding kinds of approaches. So one of the things that Lyle did not tell you about is that he's also produced another budget back there, budget sheet. You've got the two big folded presentations on the full-blown enterprise budgets, but then there's a single sheet there that he's also provided that we decided, well, how about if we do a little bit of a modification of what we see others doing that he had the hard data for, and start off our long-term looking at maybe minimal chemical treatments to approximate or kind of come into the same ballpark that we already know from current data that the conventional tillage operations are producing. So try to get that, the same operational costs, or at least around the same, so that we get the same roughly bottom line, and see how that then compares early on, and we go forward. So there's a lot of things that we're allowing ourselves to do with this more long-term approach that maybe we haven't been able to do in the past. One of the other things that we've worked into the new current research that I've heard pop up several times in questions is not only do we want to look at the tillage treatments, and out at the Blue Creek we have 8 total treatments and 3 replications going on out there. The tillage treatments are conventional tillage and no-till with the chemical fallow. But then we've thrown in this idea that people have mentioned several times that maybe there's some modification to tillage that needs to happen to promote some of the weed germination that would allow the chemical fallow to have more effect, particularly on things like the jointed goat grass and other things. So we put in a reduced tillage operation into this comparison with kind of a spring harrow operation with the chemical fallow. It still leaves quite a bit of residue on the surface, but hopefully maybe allows us to shatter some of those heads, mix in a little bit of that seed, get it going before we end up with the chemical fallow or chemical treatments in season as well, and do a little bit better job of weed suppression. But not only looking at the tillage systems themselves, but couple those with crop rotations where appropriate. And certainly, like we've had mentioned here, in some cases, depending on your location, your climate, some of these may not be, possible. But at the Blue Creek Station, we do have the possibility of working in rotations that might have some benefit in not only productivity and receipts, but in weed control and so forth that may not have existed in a weed fallow type system continuously out there. So we have the traditional wheat fallow. We have the wheat fallow, safflower fallow rotation there, and then also a 2-crop in 3-year period rotation where we're looking at following safflower after winter wheat with a single fallow in between. So this gives us an opportunity maybe to get additional receipts, even though there's associated increases in production costs, but additional receipts in a shorter rotation on these that might help make this more profitable down the line. So this is kind of the setup there that we have at the Blue Creek farm right now. It's up at the very east end of the farm. If you're ever out that direction and want to swing by and take a look at it, I've reproduced here. Before we get to that, we're trying to use large plot sizes as well to try to allow for spatial buffering between the plots and the use of commercial equipment on both the planting, harvesting, and other things, so that these are really more production level comparisons to what we might expect in the field. So,
is the safflower planted on fallow ground?
No, it's planted right after wheat. Yeah. So you can see how that goes. It goes. Well, we started off, everything had been in wheat, so we started off with a fallow, except for where we planted safflower right after the wheat to begin back in 2008. So far on those, we've gone through, and I'll show you later. This is our fourth year, so we're back into safflower on that 3-year rotation. So right now, but yeah, safflower follows the winter wheat crop in the subsequent spring, right after that wheat. Good question. So here's the plot layout for the, this is, you've got to commit it to memory, but it'll be nice in your notes. You can take it out there when we actually go out to the demonstration. You'll be able to take a look at a few things, and I want to identify a few really interesting side-by-side comparisons that you may take opportunity to look at while we're out there. But treatments 1 and 2 are the no-till chem fallow treatments with the 2 different full 4-year rotations. The alternate year fallows with either wheat or safflower mixed in there. 3 and 4 are the conventional with the standard wheat fallow, and the safflower one thrown in there too. And 5 and 6 are the spring harrow chem fallow with those same 2 crop rotations. We threw in the additional 2 treatments with a no-till and conventional till comparison of the 3-year rotation, the 2 crop in 3-year rotation. So they're randomly distributed throughout the field. They're in triplicate. You can see the orientation of that field there with the southeast corner noted up at the top right as you have a chance to maybe go out to the field later on. I'm going to show you a couple of things that I'd hope that maybe you take a look at, and then we'll take a look at maybe some of the early returns on some of the data that we've had out at those fields. If you look at these areas right here, you'll note that these are opportunities for side-by-side comparison between the tillage treatments on the same rotation. So 1 and 3, 5, 5, 1 and 3, those are all the wheat fallow rotations with the 3 different tillage treatments. 6 and 4 would be a really interesting side-by-side comparison between different tillage treatments with the wheat fallow, safflower fallow rotation. The 7 and 8, obviously there would be the nice little side-by-side comparison between the 2 crop and 3-year ones. So these are interesting little groupings of the way it worked out randomly that you can actually see more or less the side-by-side comparison of some of the things that are going on out in the field. And I've marked off 2 others. 7, 2, and 6 would be comparisons of the fields that are now currently planted to safflower in the different types of tillage, including the 3-year rotation there, which is 7. The interesting comparison there available to you is looking at the safflower condition following wheat compared to the safflower condition following fallow. At least visually right now, we see no difference. We'll have to see how it bears out in yield on that. Then, of course, that 4 and 8 down there, again, conventional, 2 comparisons of conventional tillage currently planted to safflower that might be interesting to look at side by side. So if you'll take those and kind of box them off for yourself, because the boxes don't show up on your handout that I've given you, that when we go out there and you have an opportunity just to wander around, you can maybe look at some of these side by side and wonder what in the heck is going on. Because I want to talk a little bit about some of the data that we've seen out there. And this is one of those things, if you don't pay attention to the past, you might be destined to repeat it. Early on, the first year of the study was 2008. We wanted to take a look at this. Most of everything had been in wheat the year before, in 2007. So we started off our study in a fallow situation, except where we had safflower in the 3-year rotations on plots 7 and 8. So everything else was in fallow. So later about mid-July, in the middle of the summer, we went out and took some detailed gravimetric soil moisture samples to take a look at the moisture contents within the different treatments there. And we saw a slight decrease in water storage in the conventional tillage, as we kind of expected that we would see, that the no-till and reduced tillage would be slightly higher overall. So you can see it in both the surface and subsurface, which are the paired bars there, surface on the left, subsurface on the right, top foot and second foot. The plots that were planted to safflower, obviously quite a bit less in soil moisture, because they were using the water actively there in terms of the crop consumption. And so, it held true that we would see lower water contents in that 2-crop in 3-year rotations, because we had those planted compared to the other 6. But we were curious whether or not that would hold then true in the following year when we came back in with the crops, to see if we in fact saw continued difference, increases in water content in the chemical fallow versus the conventional tillage, or the no-till, reduced-till approaches to the conventional. We did not see that carry through, and you can see the comparison here that the chemical, both in the surface and subsurface, the left and right groupings of these bars here, had trended lower, and in this case, we haven't done the statistics on it yet, but we believe that to be a significant difference. And we wondered, well, what was the problem here? And we thought, well, perhaps we had more growth in the chemical fallow because we had additional water early on. We had more water use, which hopefully would have translated into higher yields. Was that true? And when we went and looked at yields on those, on just the wheat planted plots there, we noted that the conventional had not significantly, but had trended consistently higher than the no-till and reduced tillage. And we were curious about that. As we've gone back and analyzed it, we realized that by starting off with minimal approaches to weed control, that we in fact had more weed pressure in the chemical fallow plots and the reduced tillage plots there than we did in the conventional. It wasn't visually striking, the difference between the fields or the plots, but as you can see in the moisture and in the yield, it did express itself there. And we thought, well, maybe we can get away with that over a few years' time. But if we go back, if we go out to the fields here, we're in the 4th year. We've been through a full rotation, and you remember what Phil said when he was up here about the 4th year is when your goat grass explosion occurred, I believe. Goat grass apparently has that in its genes, because we have that, again, the case, along with some other things. So we've got some interesting things that we're going to be looking at in terms of increasing our weed control, or making changes to our weed control routines out there, getting away from this minimalistic approach to things, and trying to look at more of the Cadillac deal, and really working on the economics of this. You had a question?
The spring on that?
I'm sorry? Oh, spring. That's the spring harrow tillage followed with chemical fallow treatment that we talked about. It's kind of the reduced tillage there. The one thing I did want to show you, Bob tells me I got about 5 minutes left, which is just perfect here. This is the yield comparison between the 2-year or 2-crop and 3-year rotations. We've only had really one full iteration of that so far on the plots, and it's interesting to note that in those cases we still have pretty competitive, anywhere from 35 to 40 bushel wheat that's being produced on that. And so perhaps introducing that additional crop in the rotation at a shorter interval is going to provide us with the opportunity to get nearly equivalent yields in the long term with an additional year of income on those fields, and that may tip the balance. And so if we look at what we've learned so far on this, that minimizing chemical inputs to try to bring these systems into more of a bottom line comparison is really not working in terms of moisture conservation and yield because of the weed pressures that are there. We got very high weed pressures, as I mentioned, right now in the chemical fallow plots that weren't entirely evident in the earlier years of doing this, where we thought we maybe could reduce our inputs, and that's not the case. The 2-crop and 3-year rotation is competing with the alternate fallow wheat production, and we've not yet run the economics on this. That's one of the things that Lyle and I really want to get after we get the yields off of the crops this year, and so we'll be able to, maybe next time we have an opportunity to talk about this, do a presentation on the budgets with that additional one in there that we may see some difference. So next year, all the plots will be in fallow, so we'll have an opportunity to really do some cleanup there of the weed infestations, begin to evaluate the additional things that we talked about earlier on, the weed seed bank counts, the carbon accumulation, soil structure, and those things that are really hard to value. We were just having a discussion a while back with Earl, how do we put value on those kinds of things. There are approaches out there that at least would provide incentive to the adoption of no-till in dry land. Should we have opportunity to niche market, some of the things like carbon accumulation and carbon credits that we would maybe be able to get additional revenue streams from, and looking at the economics of that 2-crop and 3-year rotation.